क्या हाल है? ओके, आज हम लोग पढ़े टुडे वी विल डिस्कस ओहम्स लॉ. Firstly, we will discuss its statement. The current applied to the conductor then voltage supply across its end constant resistance. As we know about how current supply, how voltage applied, and what is the role of resistance. Here current is directly proportional to the voltage. I directly proportional voltage. I represent current, V represent voltage. I is equal RV या VR. VR लिख सकते हैं. Okay. We can write V is equal IR also, because current and voltage both are directly proportional. V also directly proportional I. So if proportionality constant here, it would be V is equal IR. This is known as Ohm's law. Ohm's law. Unit, we know that the unit of voltage is volt, unit of current is equal ampere. We can find out resistance unit. V is equal IR, R here, V over I, volt over ampere, volt per ampere. This is unit of resistance, and its SI unit would be ohm, which is represented as this symbol. If we talk about resistance, what is resistance? Resistance basically is the property of substance which is provide opposition to the flow of current, right?
Yes.
It is totally against the flow of current and flow of charge, the current. This is resistance. Resistance means रुकावट, against, opposition कह सकते हैं. There are two terms, ohmic and non-ohmic. Its name represent materials that obey Ohm's law that we discussed here. Materials that do not obey. Its name represent non-materials that doesn't obey Ohm's law. First difference. Second, linear relation. We can understand it by graph. This is the relation: voltage on y-axis, current on x-axis. This will remain constant. If current increases, voltage also increases. But in non-ohmic, it can vary from top to bottom, from bottom to top. The next difference is resistance constant, because in Ohm's law resistance always constant. Here vary or differ. With the passage of time, it can change. Who? Resistance, Ohms. Okay, this is ohmic and non-ohmic. If we talk about its example, it would metal. All metal obey Ohm's law, so they are ohmic conductor. Conductor that can pass electricity obeys Ohm's law. Here thermistor, lamp. Thermistor in which resistance can vary. When current increase, resistance decrease, because both are inversely proportional. If current increase, resistance also decrease. Current increase due to flow of charges and provide heat. That's why current increase and resistance decrease. This is ohmic and non-ohmic conductor. Now we will discuss factor affecting resistance. What are the factors that affect resistance? Firstly, we talk about cross-sectional area. That is represented by capital A. Secondly, we will discuss length of wire or pipe. We know that current passing from a wire, which is a good conductor like copper. Here density also factor represented by. Clear? Yes. Here we will talk about copper, wire and a pipe. Pipe from which water flow of water. Basically, resistance means opposition that stunt its flow. Stunt flow. During flow of water, flow of current, here they are telling us about flow of water in pipe. If the length of pipe increase, there would be obviously greater resistance, because resistance always directly proportional as. If length increase, obviously there are a lot of hurdles, a lot of difficulties during flow of water and current. Resistance also increase because length of water or wire increase. Then we will talk about area. Resistance always inversely proportional to area. Then area of wire. Incline, resistance decline. It's inverse relation between them. If we compare first equation here, second, compare both first and second equation. R directly proportional L, we can write it as R directly proportional L over A. To eliminate proportionality, we can replace proportionality with density, rho. R is equal rho L over area. This is the main relation between resistance, length and cross-sectional area. How resistance affects length as well as cross-sectional area. If we talk about density and resistance, they are both also direct relation. We know that density represents viscosity, right? Yes. Viscosity of fluid or any liquid fluid. If something like fluid is viscous, viscous means gada. Viscous, the flow of water or liquid will be minimized because there are resistance occur due to strong viscosity. So they both are directly proportional to each other. Okay. Now I am asking questions to you class. What is the relation between resistance and length? What is the relationship between resistance and cross-sectional area? If cross-sectional area increase, then what will happen with resistance? Because both have inverse. What is the relationship between resistance and density? If one increase, what do you know about Ohm's law? What are ohmic conductors? What are non-ohmic conductors? Tomorrow will be your assessment of these topics that we discussed here. Okay?